So we're going to start polynomials. It's a pretty easy lesson today. We're just going to go back to grade 9. This is when you learned what a polynomial was. So polynomials are in the form f of x equals a sub n x to the power n plus a n minus 1, blah, blah, blah. So you'll notice that the x's go down in degree, yes? The x exponents go down in degree. So the thing to make it a polynomial is these powers here, n minus 1, etc., has to be a whole number, okay? And x is the variable. A naught, a1, blah, 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 to an are rational numbers, okay? The degree, do you remember the term the degree? The degree of the polynomial is n. That is the exponent of the greatest power of x. The leading coefficient, so all these terms hopefully are familiar. The leading coefficient is a and the coefficient of the greatest power of x. And does anybody know what a sub 0 or a naught is referred to? It doesn't have an x attached to it. Starts with a c, a constant, because it doesn't vary. The constant term is a naught. Okay, so knowing all these properties of polynomials, let's identify if this is a polynomial, and if it is, you're supposed to state the degree, the leading coefficient, and the constant term. So, a f of x equals 3 to the power x. Is that a polynomial? What is this? This is an exponential function, right? When you have an x as a power, okay, maybe I'll have to refer back to our definition of what a polynomial is. X's have to be not as an exponent. The exponents have to be whole numbers. And the coefficients can be rational, meaning they can be any number. Okay, so this is not a polynomial, this is an exponential function. Okay, how about this one? Y equals 3x to the power 15 minus 2x to the power 7 plus x minus 17. Is this a polynomial? Yes, this is a polynomial. So what is the degree? The degree, again, is what? Highest power of x, 15. Then it says, what is the leading coefficient? That is the coefficient of the power that has the highest degree, 3. And what is the constant term? Minus 17. It has to be a minus, right? Because they're all add otherwise. Okay, next one. Is that a polynomial? I'll go back to the definition. N, that's the exponents there, has to be a whole number. Is -4 a whole number? No, it's an integer, so this is not. Does anybody know what the name of this function is called? No. Huh? You learned this in grade 11. When you have x to the power -4, how do you make that positive? It goes to the denominator. What happens when you have you could say it's a reciprocal function, or you could just say it's a rational function, right? Okay, next one. H of x equals 3x cubed minus 5 root x. Is that a polynomial? I will go back to the definition. N has to be a whole number, meaning the exponents have to be a whole number. What is this exponent right here? It's a half. Is that a whole number? No, so that is not a polynomial. That's a mixture of two different types of functions, so it would be hard to name it. Okay, E, is that a polynomial function? You're afraid to say yes now? It is a polynomial function. What were you worried about as the reason why it wouldn't be? You weren't worried. You were confident. Okay, good. It is a polynomial function. So what's my degree? It is 5. What's my leading coefficient? Pi. And what is my constant? Yeah, positive 7. Okay. Is that a polynomial function? Well, this is kind of a gray area. You could argue it actually is. It's more descriptive as a constant function, but it actually meets all the definition of a polynomial function, right? So technically it is. It's just better described as a constant function, right? So the degree would be what? Is there an x there? No, so then how can it be 1? So what would the degree be? 0. The leading coefficient and the constant are the same thing, right? So that's why I'm saying it's kind of this is kind of a gray area. This is really a constant function. I mean 9. Okay, this is going to be a really hard question now. Does everybody remember how to use long division to determine this quotient? No calculator. Old school. Putting the 13 in and going like this. Do you remember how to do this? Okay, I'll give you a moment to do that. Okay, so 13 goes into 27 twice. Remember, you got to remember the method because this is now going to get applied to a polynomial. So 2 times 13 is 26. And then we subtract. Then we bring this down. Does this ring a bell for people? 13 goes into 14 once. Subtract. Bring this down. 13 goes into 18 once. And then when you got really good, when you got older, you'd actually start adding zeros, a decimal and then zeros. But we're just going to leave it as a remainder. And we're not going to be like remainder 5. What do we usually do then? What's my answer? 211. Not plus 5. 5 over 13. That's how we used to write it, yes? Yeah. Okay. So I think I'm going to keep going, but I'm going to stop this.